Hi, I'm Michelle Sheran-Andrews, and in this video, I'll talk you through the Deriving Cost Functions help sheet. Before reading the help sheet, be sure you can recall these concepts and definitions. This list and the others in the help sheet are posted on Sakai. Now you're ready to read and study the help sheet. After doing so, make sure you take time to explain in your own words the steps to derive both the short and long-run cost functions. Now you're ready to get practice applying these steps. Let's work this problem. Given this production function, let's start by deriving the long-run cost functions. To derive the long-run cost functions, first step is to derive the MRTS. In the second step, we will set the MRTS equal to the slope of the isocost line and solve for capital. This is called the expansion path. In the third step, we will plug the expansion path back into the production function and solve for labor. Now we have derived the labor demand function. The fourth step is to plug the labor demand function back into the expansion path and then solve for capital. We've now derived the demand function for capital. In the fifth step, we will plug labor demand and capital demand into the isocost equation. We now have the long-run total cost function. To derive the marginal cost, take the derivative of total cost with respect to Q. Here we get a constant WR over W plus R. To get average total cost, divide total cost by Q. Once again, here we get a constant WR over W plus R. So in this example, marginal cost equals average total cost equals a constant equal to the value WR over W plus R. Now suppose capital is fixed at a quantity K bar units in the short run. Let's derive the equations for the short run cost functions. The first step here is to plug the fixed value of capital into the production function and solve for labor. Now we want to plug the short-run labor demand function and the fixed value for capital into the isocost equation. That's the short-run total cost function. To derive the marginal cost, take the derivative of total cost with respect to Q. To derive the short-run variable cost equation, recognize that this portion of the total cost function varies with quantity because it has a Q in it, whereas this portion does not vary with quantity because there's no Q in it. This means that the variable cost equation is W times Q to the 1/2 minus K to the 1/2 all squared. Average variable cost is variable cost divided by Q. So here we get the following equation. Average fixed cost is fixed cost divided by Q. Here, fixed cost is R times K bar. So average fixed cost is R times K bar divided by Q. Now lastly, average total cost is total cost divided by Q, which in this case gives us this equation. Notice that average total cost is also the sum of average variable and average fixed costs. Now you're ready to go beyond the surface of this help sheet by analyzing and evaluating. Be sure you take time to look at these points and bring them to recitation. Last, create by working through these concepts and skills. That's it. This concludes the Deriving Cost Functions video.